This is a photo of the Suzuki AX100 that I had when I lived in Paraguay. It's a bike that's sold worldwide in most countries. Maybe not in some of the European Union countries, maybe, and definitely not in the United States. But in third world countries, it's a very popular bike. And it only lacks one thing to really get it up and going, and that's a little bit of porting. Here in Ecuador, there's AX100s that are actual very good copies of the Suzuki. And they come with a slightly larger carburetor. The stock Suzuki comes with a 20 millimeter. The one that my friend Paul bought here in Ecuador has a 22. And this thing was very surprising in its power output. My bike, I did a lot of modifications to it. I put a different ignition system in it. I raised the exhaust port. I put a different exhaust pipe on it. I changed the jetting. And it was peppy, but it wasn't as surprisingly fast as this bike that my friend Paul has. The stock bike only has half a reed valve. It has this one pedal that goes down into the crankcase. Even with that limitation and a 20 millimeter carb, if you port it right, it can get up and go. It can be really fun bike. So this is the porting map of the standard Suzuki AX100. It's got an exhaust duration of 169 degrees and transfers of 124. 124 is higher than what you would expect, but it's doing that to compensate for the lack of transfer space. These are the boost ports, and then it's only got a right side transfer and a left side transfer. So usually with limited transfer space, you have to compensate for it with a higher duration. But that only gives 22.5 degrees of blowdown. The difference between the top of the exhaust port and the top of the transfers is the blowdown. So at 9,000 RPM, which is the top RPM of this bike, my porting calculator says that the combustion pressure doesn't alleviate until this distance from here to bottom dead center has gone down 32% of that distance, which means that's the time at which the transfers do not transfer the intake charge into the cylinder. It has to wait for that combustion pressure to dissipate through the exhaust port. So it's lacking in blowdown. So I alleviated that by raising the exhaust port by 3.5 millimeters. And that, on my porting calculator, changed the end RPM of adequate intake from 5,500 to 6,750. And it made it a lot peppier. It was a fun bike to ride. And it still had good low-down power too, which is what you need in the street. Sometimes you just, barely give it any throttle at all, and that's the way street bikes should be. But this other Suzuki that my friend Paul bought had the same raising of the exhaust port, but it also raised the transfers 1.5 millimeter. And it brought the blowdown to 26.5 degrees. Mine was 29.5. So this is the question. What is more important, the blowdown or the height of the transfers? Inadequate blowdown limits the power at high RPM. Limited transfer height also limits the power at high RPM. So that's the reason for my porting calculator. This is it. And here's the graph that shows when this green graph starts to dip down below 1.0. Right at that knee right there is the RPM at which the best torque starts dropping off. That's usually about the peak horsepower, but it also depends upon the exhaust pipe. So this program allows you to see where that knee happens with different porting changes. This is Paul's bike, and it shows that knee is right about 7750, 8000, which is about 1000 or 1200 higher than what my AX had. The beauty about using computer programs is that it eliminates the guessing game. Before you're guessing, well, what's more important, the blowdown or the transfer height. With this program, you can experiment with different combinations and see the result in the graph. So here's the three graphs. The stock AX, where that knee happens, is at 5500. My AX, where that knee happens, is at 6750. And Paul's AX, which is 7750. So this is a bland street ride. This is a peppy street ride. And this is hold your hat on, mama. This thing is going fast. This bike is actually scary fast. Riding amongst these Latinos, I'd be scared of winding up in the hospital. So I wouldn't even port it that high. If I had another one, I would choose some middle ground between these two. I'd raise the exhaust port that high, but I'd raise this maybe 0.7 millimeters. See how it ran if I wanted a little bit peppy. Because with Paul's bike, it's fun. It's fast. It'd be good for racing on the street. But at the very low RPM, it barely wants to go. So it's a little bit overported for the street, unless you're doing street racing. So it's more critical on how you use the clutch with this porting arrangement. Yeah, that's it. On my bike, I changed the reed valve out to from the steel to carbon fiber and then to fiberglass. I changed the exhaust pipe to have a more effective diffuser. I tried a boost bottle for a while. Finally took it off after I settled on the pipe having this design. That's the CDI I made for it. Grooves are more effective than dimples, in case you're wondering what that is. So yeah, the only other thing I really don't like about the stock bike is it's so low. You can't tell by looking at this picture unless you put it side by side with a stock one, but this is about 2 inches higher on both ends. I had the machine shop make an extension of the forks that I put here, and I bought longer shocks to put in the back. So to keep the same geometry, I raised both the front and the back of the bike. And with it raised up a couple inches, it felt more normal. The stock bike just feels too squat. As a side note, if you're in a third world country and you're considering buying the Suzuki, for a few $100s more, you can get something really nice. And it's got a better 5-speed. It's got better suspension. It's got a full reed valve. And that's a Yamaha RX 135. They also have a 115 and maybe a 100 also. So that's it for now. Thanks for watching. Like and subscribe.